This section is based on changing speed. Okay, when we talk about changing speed, we're basically talking about acceleration, deceleration, okay, constant speeds. And obviously one of the key things that you will have to tackle are speed time graphs. We'll talk about units in a little bit, so I'm not going to specify the units in this particular case. So speed goes on a y-axis and time will always be on our x-axis. You might see something like this being produced. Okay, in the case of a nice straight line, okay, that goes up, what we're talking about is how the speed is increasing as time passes. And because it is a straight line, that tells you that the increase in speed is the same, okay, for every second or every minute, okay, the object is moving. So this would be a constant acceleration. Acceleration obviously meaning increase in speed. Okay, getting faster. When you have a flat line on a speed time graph, what we're basically saying is over this period of time from here to here, the speed has not changed. So this would be described as a steady speed, okay, or a constant speed where the speed doesn't actually alter. When your line goes downwards, again in this amount of time, the speed has got less. And again, because it's a straight line, it is a constant, and in this case, deceleration, okay, which is slowing down. Now, you may see in exams the term positive and negative acceleration actually used. Basically, acceleration where you get an increase in speed, that's called a positive acceleration. And when you have a decrease in speed, it's technically called a negative acceleration. However, we better know it as deceleration. So in this particular graph, we can obviously see key things. We can see how the acceleration and the change in speed has got faster, stayed at the same speed for a period of time, and then slowed down. You may also get lines that are slightly different on your graph. So you may get a line like this, for example, with a curve. And that's basically non-uniform. A straight line is a uniform acceleration, and a curved line is non-uniform. If it goes in this direction, that is because the acceleration is decreasing. So you may have started out going at, let's say, for example, 5 meters per second. However, that starts to then get less, and by the end of it, around here, we might be at only 2 meters per second. So going in that direction, we're talking about acceleration decreasing. The opposite, where you might have a line, for example, that goes like this, that would be indicating a non-uniform acceleration, but the acceleration would be getting more. So it's an increase in acceleration. Now, acceleration is how speed changes over time. And acceleration is used and measured in this unit, or written as this, which is meters per second per second. Meters per second is the unit of speed, and then we're looking at how that speed changes over time, or in this case, how that speed changes every single second. So when we look and we focus on a speed time graph, let's say we use typical scientific units of meters per second and seconds for time. What we have the ability to do is actually to calculate certain key things, and one of those things that we can calculate is actually the acceleration, especially if it is a uniform straight line. In fact, you won't be asked anything else. So let's say we have a graph and we have a line and we've got speed in meters per second and we have got time in seconds. What you could do is you can work out what the acceleration is, okay, using the acceleration equation. Now, the first thing you can do for this particular section on the graph, sometimes they might divide it into, for example, a part of it and label it, for example, A. But you can deal with this in pretty much the same way. You look at the time it takes, okay, for the section. And if we separate it into this area, it will be from here to here. So let's say the time goes from 2 to 5 seconds. And then we look at how the distance has changed from here to here. And let's say it goes from 5 to 15. Okay, let's make our numbers nice and easy. When you're calculating acceleration, it is speed, or in this case, the change in speed, divided by the time that it takes for that change in speed to happen over. So the change in speed for this section of the graph is from 5 to 15. So the change in speed is going to be 10 meters per second. And we're going to divide that by the time it takes to actually carry out that change, which is from 2 to 5. So the time taken is 3 seconds. And that will give you a value in meters per second squared, or meters per second per second. Other things you can tell from these graphs are also related to distance. Okay, you can actually work out the distance that was travelled. In this case, it would be in meters, by looking at the area under the graph. And that's no different to how you calculate area underneath a shape, or within a shape in maths. Break it into sections, triangles and rectangles in this particular case, and then work out the area for each section. So if it's asking for the total distance, you'd need to know the total area under the graph. If it's asking for the distance travelled at steady speed, you would only work out the area underneath that specific section of the graph. You wouldn't work out anything else. So speed time graphs are good for calculating acceleration and for distance that is travelled in a particular part of the graph, or potentially for the whole of the journey. So other things that you might have to tackle linked to changing speed. Okay, we've covered and we've looked at acceleration. We've also looked at the idea of speed time graphs. When we look at acceleration in a little bit more detail, it's important to understand what acceleration actually means. Now, most people, when they talk about acceleration, they are talking about change in speed. So when people talk about the fact they're accelerating quickly, for example, so the acceleration is high, what we're talking about is how the speed is changing over a particular time. However, acceleration doesn't just mean that, because acceleration also includes, when we look at not just speed, but also direction. So acceleration is not just about speed, it is about direction as well. So change in speed, yes, would mean acceleration, but also change in direction is also acceleration. And also, if speed and direction change, again, that would be acceleration. I'll give you a perfect example. A roundabout. Okay, you have a roundabout and a car going around that roundabout. Now, obviously, if that car changes speed, it would be acceleration. So if it slows down, it'd be a negative acceleration. If it speeds up, it'd be a positive acceleration. Okay. However, if that car goes around the roundabout at a constant speed as it travels, it will also be accelerating. And the reason why it's accelerating is as it goes around the roundabout, its direction changes. So acceleration isn't just about changing speed, it's also about changing direction, okay? And the reason why that is the case is that acceleration is actually change in velocity. Now again, in science, we use velocity to pretty much mean speed. But actually speed is not the only thing that is included in velocity, because velocity is speed with direction. So because acceleration is a change in velocity, that means if you change the speed or if you change the direction, you are technically accelerating. Another area that potentially you might have to deal with are questions linked to relative velocities. Now, relative velocities, I'm not going to go into why this is the case. I more want to focus on how you would tackle, okay, questions. You may have noticed that if, for example, you are on a dual carriageway okay, and you are going at a particular speed. As you drive along, you're going in this direction, so you have a particular velocity. If a car overtakes you, the car will appear to be moving fairly slowly, okay, from your perspective, okay, of you being in this vehicle here. So as it overtakes, as you watch it overtake, it'll appear to go relatively slowly compared to you. Let's say, for example, you're actually going at 60 miles per hour and the vehicle overtaking you is just going slightly above you at 63 miles per hour. Okay, so it will feel like the overtake is relatively slow. If, however, we do it in opposite directions, so this is in the same direction, and let's say again you're traveling along a road, it's just a normal single carriage, okay, road, you're going at 60 miles per hour, okay, on a single carriage, that's the most you can go up to, and you're going in this direction, okay, so there's you, and the car opposite you is coming in the opposite direction at 63 miles per hour. As that car overtakes, it will feel as if it's going very, very fast. Okay, and this is what relative velocities are about. When it comes to working out questions, there is a nice, easy way to actually be able to do this. If the two cars are moving basically in the same direction, okay, so same direction, you take the speeds away from each other. So it's minus speeds. So that means the relative velocity will be the difference between 60 and 63. So the relative velocity will be 3 miles per hour. Okay, that's quite a slow speed. If you are going in opposite directions, like in this case, you do something difficult. You add the speeds. So the relative velocity in this particular case will be a combination of 60 and 63, so that will equal 123 miles per hour. No wonder it feels like it's going past you with such speed. If you're asked to explain why you've worked out the relative velocity, I've seen kind of multiple choice, they'll give you a range of possible answers, you choose the correct relative velocity. They'll obviously always give you both possibilities, okay? How do you explain it? Well, you just talk about this. So if, for example, you're given a situation like this, you choose it's 3 miles per hour, okay, the relative velocity. Why is it 3 miles per hour? Because they are going in the same direction. Why in this case would it be 123 miles per hour? The reason why is going in the opposite direction. Okay, so that's the easiest way to deal with questions like that. So changing speed is about relative velocities, speed time graphs, and acceleration.